We want to find the x-intercepts and the y-intercept of the function. F of x equals x cubed plus 2x squared minus 9x minus 18. So we're looking for the intercepts, and I find it's usually a little bit easier to find a y-intercept than an x-intercept. So I'll find the y-intercept first. And to find a y-intercept, you want to let x equal 0. And when you let x equal 0, you know that your point will have to be on the y-axis. So we're going to substitute a 0 in for x. That's 0 cubed plus 2 times 0 squared minus 9 times 0 minus 18. And 0 cubed is 0. 0 squared is 0 times 2 is 0. 9 times 0 is 0. And we can combine all that together to get negative 18. So we're going to have a y-intercept, which is 0, negative 18. And then let's find our x-intercept. We find an x-intercept by letting y equal 0. So this guarantees that our point is going to be on the x-axis. And I don't see a y in my equation, so I have to remember that these symbols, f of x, is the same thing as y. I'm going to change that f of x to 0. And when I do that, I'll have the equation 0 equals x cubed plus 2x squared minus 9x minus 18. So I need to solve this equation, and this equation I would call a polynomial equation, and we have a third degree polynomial. That's the highest power. And in our class, the method that we're going to be using for solving polynomial equations is going to be factoring. Now, not every polynomial can be factored, but we're only going to do in this class the ones that can be factored. If you move on to higher level classes, you'll learn other techniques for solving polynomial equations. So when I'm thinking about factoring, the first thing I always do is to take a look at every term to see if there are any common factors. So I'm looking at the variables, and there are a variable of x in the first 3 terms, but not in the last. So we don't have a common x. And then I'm looking at the coefficients, the numbers attached to the variables, to see if there's any common factor between them, and we don't have any common factor. So we're not able to factor the greatest common factor. So then I'm going to think of some of my other techniques. And this particular polynomial has 4 terms. And this is a clue to me to use a method that's called grouping. So whenever you see 4 terms, use that as a clue to try this technique. It doesn't always work, but I believe it'll work on this example. So when you group, you're going to take 2 terms at a time. So I'm going to group x cubed with 2x squared. And then I'm going to group negative 9x with negative 18. And in each one of the groups, you're going to look for the greatest common factor. So for the first group, I've got x cubed and x squared. So I have a common factor of x squared, and I'm going to factor it out of that group. Factor the x squared out, and you're left with x plus 2. And then you look at the other group, and you also look for a common factor, the greatest common factor. This group is negative 9x minus 18. The 9 and the 18 have a greatest common factor of 9. 9 goes into 9, 9 goes into 18. I also have a negative here, and so I want to factor that negative out as well. So I'm factoring -9 out, and I'll be left with x plus 2. Double check here to make sure it works, and the way you check factoring is by multiplying. So if I multiply -9 by this, -9x is -9x. -9 times +2 is -18. X squared times x does give you x cubed. X squared times 2 does give you 2x squared. So we've checked our factoring, and it's correct so far. Let me erase these marks. So the next thing we're going to do is you're going to check inside the parentheses. And if this grouping method is going to work, what's inside the parentheses should match. And it does. And because it matches, that means that we can factor a common factor out again. So thinking of this term and this term, we have a common factor of x plus 2. So we're going to factor that common factor out of x plus 2. And when we factor that common factor out, what's left is x squared minus 9. And then inside these parentheses, this x squared minus 9 is another special case of factoring called the difference of squares. And so we're going to be able to factor that more. X squared minus 9 is x plus 3 times x minus 3. So we factored that completely. And then we're going to use the zero product property and set each factor equal to 0. And we subtract 2, subtract 3, and add 3. And get x equals -2, x equals -3, and x equals +3. So we have 3 x-intercepts. It's -2, 0, -3, 0, and 3, 0. So we found all of the intercepts of this polynomial function. On this question, we want to find the x-intercepts and the y-intercepts of the function p of x equals 2x cubed plus 21x squared plus 27x. So we're looking for those intercepts, and I find usually the y-intercept is a little bit easier, so let's start with that one. So to find a y-intercept, you're going to let x equal 0. We're going to substitute a 0 into our function, and that gives 2 times 0 cubed plus 21 times 0 squared plus 27 times 0. 0 cubed is 0 times 2 is 0. 0 squared is 0 times 21 is 0. And 27 times 0 is 0. So we are going to have a y-intercept at the origin 0, 0. Now let's find those x-intercepts. To find the x-intercept, you're going to let y equal 0. Now we don't have a y here, but we know this p of x is the same thing as y. So we're going to let p of x equal 0, and that's going to give us this equation. 0 equals 2x cubed plus 21x squared plus 27x. So this equation is a polynomial equation of degree 3. And what we're going to do is solve this polynomial equation by factoring. And the first step that you should do in factoring is to look for common factors. So I do notice that every term has an x in it. So we're going to have a greatest common factor of x. And if we look at the coefficients on all of these x's, I have a 2, which is an even number, and the other two numbers are not even, so 2 is not going to go into that, so I know I don't have any common factors. So the only common factor is the x. So I'm going to factor out the x, and that will leave me with 2x squared plus 21x plus 27. So then I want to try to factor more. I want to look inside these parentheses and try to factor 2x squared plus 21x plus 27. So that is a quadratic. And there are different techniques for factoring quadratics. I like to use a method that I call trial and error or guess and check. But a lot of people are not comfortable with that method and they prefer a method that is sometimes called grouping. But I'll show you a couple different ways that you can factor this. So let's kind of on the side over here write down our quadratic that we're trying to factor. 2x squared plus 21x plus 27. And I'll start with my guess and check method for trying to solve this. So with the guess and check method or trial and error, you're going to set up two binomials. The numbers that go in the front need to multiply to be this first term here. And luckily 2 only has one pair of factors, 1 times 2. So we don't have a whole lot of choices, a lot of guesses for what goes in the front. So I can only put 2x and x. Those are the only pair of numbers that will give us 2x squared. Now the numbers that go in the back need to multiply to be this last term here. We're not quite as lucky here because 27 has more factors. So let's write down what are the factors of 27. So 27 is 1 times 27, or 3 times 9. And I guess there's not that many, so that's okay. So what we want to do is we want to guess which one of these is going to work. And then in the middle, we have this 21, and we need to make sure that whatever numbers we pick are going to make the right number in the middle. So let's try the 1 and the 27. So if I try the 1 here and the 27 here, that's my guess. This is my guess. And now I'm going to check to see if that's right. Now we have already guaranteed that the first two terms multiply correctly. 2x times x is 2x squared. And we've already guaranteed that the last two multiply correctly. 1 times 27 will give us the 27. So when I check, I don't need to check everything. I only need to check that the middle number is right. And I'm going to check that middle number by multiplying these two inside terms and these two outside terms. So when I multiply those two together, I get 1 times x, which is x, 27 times 2x, which will be how much? 27 times 2. $54. 54x. And 54x and x don't add up to be the middle term of 21x. So this guess is wrong. So we're going to move on to another guess. Now, normally if I was doing this just for myself, I would do some erasing here and change things around. But for you guys, I'm going to write out all the guesses so you can see the process I'm going through. So we've already guaranteed that 2x is right and x. And we're going to switch up. I'm going to put the 27 here and the 1 here. And we're going to check the middle terms. 27 times x is 27x. 2x times 1 is 2x. And if we add those together or subtract those, 27 and 2 cannot make the correct middle term. So this guess is wrong too. Let's try another guess. So I'm going to put the 2x and the x, and I've exhausted 1 and 27. So now I'm going to try 3 and 9. So let's try the 3 and 9. Inside is 3x, outside is 18x. 18x and 3x add up to be 21x. So this is a good guess, and I just need to put my pluses here. And now I have factored this as 2x plus 3 times x plus 9, and that's the correct factorization. So I have x times 2x plus 3 times x plus 9. I can now solve this equation with the zero product property, setting each factor equal to 0. X equals 0 is one solution. I'll subtract 3, that gives 2x equals negative 3. Divide by 2, x equals negative 2 over 3, negative 3 over 2. Here I'll subtract 9 and get x equals negative 9. So I have 3 x-intercepts, that's 0, 0, negative 3 over 2, 0, and negative 9, 0. So I showed you how to factor that with the guess and check method. Let me show you one more method that you might like better. So I'm going over here and I'm going to write down this quadratic again, 2x squared plus 21x plus 27. And this is a method, I call it the AC method. Some people call it crazy X. But what you do in this method is you multiply the 2 and the 27 together. So you do 2 times 27, and that is 54. And then you're going to look for two numbers that multiply to be 54 and that add to be 21. So I'm going to write down the factors of 54, because the factors of 54 are going to be two numbers that multiply to be 54. So that's 1 and 54, 2 and 27. 3 goes into 54, let's see, 18 times. 4 doesn't go in there. 9 does. 9 times, I guess I skipped some numbers. 6 times 9. And these are all the factors of 54. So once you get those numbers, once you get those pairs, you want to add them and subtract them. So if you add 1 and 54, that's 55. If you subtract them, you get 53. If you add 2 and 27, you get 29. If you subtract 2 and 27, you get 25. If you add 18 and 3, you get 21. If you subtract them, you get 15. If you add 6 and 9, you get 15, and if you subtract them, you get 3. And remember what we were looking for. We were looking for numbers that add to be 21. So we've got that right here with this pair. So this is the pair that we want to use because it did what we wanted. It multiplies to be 54 and adds to be 21. So what you're going to do is you're going to take that 21 and you're going to split it, and you're going to split it using the numbers that you just found. So let's rewrite this as 2x squared plus 3x plus 18x plus 27. Now that you have 4 terms, you're going to use a grouping method. So you're going to group 2x squared plus 3x, and you're going to group 18x plus 27, and you're going to factor the greatest common factor out of each group. So for the first group, 2x squared plus 3x has a greatest common factor of x. That leaves you with 2x plus 3. And for the second group, 18x plus 27 has a common factor of 9, and that will leave you with 2x plus 3. What's in the parentheses match each other, and so we're going to be able to factor out the common 2x plus 3, and you're going to be left with x plus 9. And so now you factored completely the same way that we factored with that guess and check or trial and error method. Okay, so I've shown you 2 different ways that you can factor that quadratic. And as I mentioned before, once you factor it, you set each factor equal to 0 to get those x-intercepts. So let me show you the final answer one more time. We have a y-intercept of 0, 0, an x-intercept of 0, 0, negative 3 over 2, 0, and negative 9, 0. Thank you for checking out my videos. Have a great day.